Moving forward, the next team presenting is SymBL Innovations. SymBL uses microbiomes to convert organic waste into valuable industrial chemicals currently sourced from palm oil. My apologies. They cut emissions, reduce supply chain risk, and turn waste into profit. To present SymBL Innovations, we have Connor. Connor, over to you.
I'm Connor. I'm a master's in chemical engineering, and I'm co-founder of SymBL. SymBL is a startup from the University of Toronto that's leveraging the power and efficiency of biology to extract more value from organic waste. So humans produce over 1 billion tons of organic waste every year, and much of that is still landfilled. This is a massive stockpile of carbon and energy that could otherwise be repurposed. And so that's why we're developing novel industrial biotechnology to transform organic waste into valuable chemicals instead. Our team and partners bring together experts in bioprocess engineering, synthetic biology, and clean tech commercialization, who share this vision that with bioengineering, we can circularize the chemicals industry. SymBL is targeting a class of chemicals called medium chain fatty acids, or MCFAs. And MCFAs are used by specialty chemical manufacturers to make a wide range of products for industrial purposes, food and beverage, agriculture, and cosmetics. The problem is that these manufacturers have to import MCFAs from palm kernel oil sources in Southeast Asia, leading to high import costs, complex supply chains that are prone to disruptions, yield and composition variability due to climate change, and deforestation and greenhouse gas emissions. With SymBL's biotechnology, we can produce MCFAs domestically from municipal food waste instead, saving these manufacturers millions in import costs and supply chain losses, and delivering them a high-yield, consistent, and palm oil-free product with 65% lower life cycle emissions. Our technology also generates upwards of $20 million a year for a mid-sized municipality by converting their waste into chemicals, and it reduces their waste processing emissions by over 80%. So the MCFA market is worth over $3 billion, and we're seeing strong signals of market need for our bioproduction solution. For example, 85% of MCFA customers report challenges with the overall reputation of palm oil, the traceability of MCFAs specifically, and human rights concerns. Customer interviews also support the logistical advantages of having onshore production. And so this highlights clear market pull for consistent, domestic, and palm oil-free MCFAs produced by SymBL. We have a strong network of partners who have been deeply engaged with us and our technology over the past 3 years, including CVS, a Canadian company that uses MCFAs in animal feed, and Veolia, a global leader in organic waste processing technology. Also, we're securing over $2 million in non-dilutive funding to further R&D and piloting milestones. And we have the support of UTest and other incubators here at U of T who are delivering business mentorship and investor readiness training. So let me tell you a bit more about our technology. So organic waste bioprocessing is carried out by a microbiome, which is a diverse community of microorganisms that collaborate to degrade complex organic matter. Conventionally, that microbial community is undefined and serves more or less like a black box. So you get unwanted biological activity that diverts carbon and energy towards lower value, less desirable outputs like biogas or short-chain fatty acids. But with SymBL's bioengineering pipeline, we engineer microbiomes from the bottom up to redirect that carbon and energy towards MCFAs, resulting in higher yields and greater selectivities. We use a combination of genomic tools, high-throughput lab automation, and machine learning to engineer microbiomes. And we've already shown in the lab that we can achieve 2 times higher MCFA yields compared to conventional fermentation methods. So what else sets us apart from our competitors? Well, the MCFA market spans diverse end-use sectors like agriculture, pharmaceuticals, and personal care. And importantly, these end-use sectors require different lengths of MCFAs, ranging from 6 carbons to 12 carbons. Conventional fermentation methods used by our competitors are mainly limited to C6 production, which really constrains their market opportunity and makes finding high volume, consistent offtake a real bottleneck. This also means that most MCFA customers have to rely on palm and other seed oil sources. But with SymBL's microbiome engineering technology, we will be first to market with C6 through C12 bioproduction, offering consistent, domestic, and palm oil-free MCFAs to customers across these segments, which will facilitate finding that high volume offtake for our product. To commercialize SymBL's MCFA technology, lab validation and a voice of customer campaign are currently underway. This will establish our minimal viable product and our go-to-market strategy, feeding into a seed round and field pilot with key partners in early 2027. This will validate scalability and allow us to build out culture manufacturing and sales capacity, with the aim being of securing MCFA customer MOUs. Then we plan to execute a commercial demonstration through a joint venture with strategic partners, which will lay the foundations for full-scale commercial rollout. And at scale, SymBL will generate revenue through an asset-light model that leverages the expertise of strategic partners. We will license our engineered microbiomes and provide technical support to municipalities and to their plant operators. This will allow them to generate MCFAs from their organic waste. And in exchange, SymBL will capture value during plant design, construction, and operation through royalties on MCFA sales, as well as one-time and recurring service and licensing fees. SymBL is founded in Dr. Lawson's lab here at U of T, who's an internationally recognized expert in anaerobic biotechnology and is CEO. Once again, I'm Connor, I'm CFO, and I have 4 years of cross-disciplinary experience in life sciences, engineering, and finance. Ethan Agina is COO, bringing over 8 years of experience leading and managing synthetic biology projects. And Joel Howard is CTO with over 6 years experience in lab automation, bioinformatics, and microbiome engineering. Our long-term vision is that with our microbiome engineering platform, we will bring precise programmable control to fermentation end products. This will enable conversion of diverse waste streams to MCFAs and to their derivatives, such as esters, diacids, and even sustainable jet fuel. In this way, SymBL will power future biorefineries and accelerate the transition to a circular economy. And with that, I'd like to thank you, and please feel free to reach out with any inquiries.
Thanks so much, Connor, for the presentation. We have a couple of questions in the chat that I'm sure you can address. First question is, who are your customers? And kind of follow up to that is, have you secured customers for an initial pilot? And if so, if you have, who?
Yeah, so for the pilot and through academic projects too, we've had a really great partner called CBS Bioplatforms. So they use MCFAs in animal feed additives where they enable better gut health and better growth yields in livestock. And so they're a Canadian company, and we've sent them samples of our product for testing, and we're working closely with them to develop a drop-in replacement for palm products.
Fantastic. And just one last question quickly. What makes SymBL's microbiome approach hard to replicate compared to the waste to chemicals and fermentation companies?
Yeah, that's a great question. So with our approach, there's lots of opportunities for us to put up some barriers, IP and otherwise. So firstly, when we design microbiomes, we combine lots of different isolates that are taken from waste. And so that bank of isolates that we use is proprietary. Also, the process we use for combining them through machine learning and automation, that's also proprietary. And we're currently working with IAC to look at key patent opportunities to do with genetic engineering and synthetic biology developments.
That's fantastic. We are at time. If you're interested in learning more about SymBL innovations, please reach out to Connor in the email on the slide. Connor, thanks again.